All right, so what I need to do here, it's asking me to compute all 6 trigonometric functions, sine, cosine, tangent, and then their reciprocals. First thing I need to do is establish the sides of the triangle. Well, across from the 90-degree angle, this is the hypotenuse, right? And the one across from the angle theta is the opposite, and then the one touching the angle theta is the adjacent, right? Now, if I think of this in terms of a squared plus b squared equals c squared, what is c always representing? Hypotenuse, right? So can I think of this as h squared? Yeah. And then over here, it doesn't matter what goes first. You could say the opposite squared plus the adjacent squared. Because a and b really are interchangeable. The one that you cannot mess up is c. C is the hypotenuse. Hypotenuse is always c. The other two, the math works out either way. All right. So and this is really important in trig. So make sure that you write that down in your paper. So what I need to do is solve for the opposite. So I'm going to plug in the numbers. So I don't know what the opposite is. But what's a? Well, a is 2/3 squared. In other words, we've got to solve for the opposite is equal to h, which is 4/5 squared, right? And then this becomes 4/9, right? Because remember that 2/3 squared is the same as 2/3 times 2/3, right? Over here, this would be 16/25, yes? Yeah. And then over here, this is just going to be o squared. We don't know what that is yet. That's the opposite squared. So I subtract 4/9 from both sides. And I get o squared is equal to 16/25 minus 4/9. Okay? So I'm going to have to take the square root of that at some point in time. This is a very, it's kind of complicated, but it's not that complicated. I need to find a common denominator for 9 and 25. Okay, what do you guys think? Huh? 225? All right, so let's do 225. Now, if we overshoot, in other words, if it's not the lowest common denominator, it'll all balance out anyways. 225 is a good number because it's a perfect square. All right, so what do I multiply 25 by to get 225? What's that? 5? 9. So, yeah, we're just cross multiplying, right? So if I multiply this, let's do it this way. If I multiply this by 9 and this by 9, what's 16 times 9? Uh-oh, I'm going to have to use my calculator on that one. So, what was it? 144. Okay. So this is going to be 144. And this will be 225. Minus, and now over here, I'm going to multiply this by 16. Not 16. 25, right? Getting ahead of myself. And then whatever I do on the top, I also have to do to the bottom, right? So this is minus 100, right? Because 4 times 25 is 4 times 25 is 100. And then 9 times 25 is 225. And then all of this is just equal to o squared, right? So when I do the math on this, I get 44 over 225. Did you guys get that?
Yeah.
Yeah? Okay. So now I just do what? Take the square root of both sides, right? So now this is an interesting thing. When I take the square root of this, I'm really going to do the square root of 45 over the square root of 225. What is the square root of 225? 15. Now, an interesting thing about 44, let me write this over to the side. This is a lot of math. 44 is the same as 4 times 11. So I can rewrite this as the square root of 4 times the square root of 11, right? Are you guys with me so far? So what is the square root of 11? Or not 11, square root of 4. Yeah, it's going to be 2 root 11 over 15, yes? And then I got to think, can I reduce the 2 and the 1 and all that stuff or no? No, not really. So then how many of you guys got the square root, or I'm sorry, 2 root 11 over 15? Oh, you guys got that? All right. So I'm going to root 11 over 15. Okay. Now, how can I double check that before I move forward? I can plug it back into a calculator and see if I get the right answer. So what I'm going to do is I'm going to plug this in and this in, take the square root of it, and then see if I get 4/5. In other words, now this is going to be a tricky one. I'm going to go the square root. Let me just go to Desmos. And we'll do the scientific calculator. So what I'm going to do is I'm going to take this, square it, add it to this and square it, then take the square root, and I should get 4/5. Okay, that's how you double check it. So I'm going to say parentheses, start my parentheses. I'm going to take the square root of, oh wait, let me back up a little bit. I'm going to say 2, the square root of 11 all over, what was that? 15. And then I'm going to square that. Plus, I'm going to say 2/3 to, oh wait, let me back up a sec. 2 over 3. Then I'm going to, oops, no, I don't like that. And I'm going to square that. And then I'm going to put that in parentheses. This is the hard part. And right here, I'm going to take the square root of that. Well, maybe not. Let me just do the math on this. So I'm going to hit enter. Okay. And I get 0.64. So now I'm going to take the square root of 0.64. And I get 0.8. Now you don't know this, but 4 divided by 5 is actually 0.8. So I did all that just to double check my math to make sure my math is right. That's the hard part. So my math is right, even though it looks very complicated. So now I'm just going to say sine, cosine, and all that other stuff. So now I'm going to say sine of theta is equal to the opposite over the hypotenuse. Okay. And so my opposite, this is a little tricky, is going to be the square root 2 over 11, or I'm sorry, 2 root 11 over 15 all over the hypotenuse, which is 4 over 15. Now, in order to simplify that, remember that we're taking this and dividing it by this fraction, right? It's like this fraction, my numerator is being divided by the denominator. So to simplify this, how do you divide by a fraction? Multiply by the reciprocal, right? Don't worry, your homework's a lot easier than this example. So I'm going to multiply by the reciprocal. 5 goes into 5 how many times? 1 time. 5 goes into 15 how many times? 3. 2 goes into 2 how many times? 1. 2 goes into 4 how many times? 2. So I've got 1 times the square root of 11 times 1. So this is just the square root of 11. What's 3 times 2? 6. So this is technically, we did all that work to get sine of theta. Now, how many of you guys got that far? How many of you guys got to this point? Okay. Let's do cosine. This is good because you get to review all these things. So cosine of theta, you guys are looking at me like, oh my gosh, is the adjacent over the hypotenuse. What's the adjacent? 2/3. What is the hypotenuse? 4/5. Same thing here. I'm going to say 2/3 multiplied by the reciprocal. Now this one's pretty easy. What's 2 times 5? 10. What's 3 times 4? 12. Can that be reduced? Yeah. We're going to divide by 2 on the top, and then we're also going to divide by 2 on the bottom. This reduces down to 5/6. Okay? That reduces down to 5/6. Any questions? Now, the beauty of this is that we can flip these to get the other ones, and I'll show you that on the next slide. So now for this one, tangent might be a little messy. Tangent of theta is going to be the opposite over the adjacent. So the opposite, oh, that was the messy one. That's going to be 2 root 11 over 15 all over the adjacent, which is 2/3. In other words, I'm going to say 2 the square root of 11 all over 15 times the quantity 3/2. Now you can cross cancel here. What's 2 divided by 2? It's just 1. So those kind of cancel each other out. And then think of it, when I do the cross canceling, 3 goes into 3 and 3 also goes into 15. So rather than multiply it out and then divide it, I could do it in the front. If I take 3 and divide it by 3, that becomes 1. If I take 15 and divide it by 3, that becomes 5, right? So then 1 times the square root of 11 times 1 is just the square root of 11, okay? And then 5 times 1 is just 5. And that's tangent. Okay? Any questions on that? Now, for the other ones, you just reciprocate it. So whatever you have, you just take the numerator and denominator and you just flip them. Does that make sense? Okay. How do you guys feel about this? Thumbs up? Yeah, not good, right? So the fractions and the square roots and stuff, don't worry, that'll get easier. The more we do it, the more we review it, the better you'll feel about that. Okay? So anyways, we'll stop there.